Question 26, this question is from real numbers. It's a classic textbook proof of proving such a number to be an irrational number. How do we go about it? We'll start by assuming the contrary. We'll be assuming that let root 5 be a rational number. What we need to prove that it is an irrational number, we are assuming to the contrary. We are assuming the opposite of it. If root 5 happens to be a rational number, as we have assumed, then root 5 can be expressed as an a by b, where a and b are co-prime integers, which essentially means that their HCF of a and b is equal to a 1. Cross multiply, you will get a is equal to root 5b. Root 5b is equal to a, or a is equal to root 5b. Square both sides, we get a square is equal to 5b square. We know this theorem, it's quite evident that therefore, because b is an integer, a is an integer, a square and b square, a square is equal to 5b square. 5 is a number that is going to divide a square. So 5 divides a square. A is an integer, b is an integer. If 5 divides a square, then necessarily 5 will have to divide a. So if 5 divides a square, it implies that 5 will divide a. So we can write a as some multiple of 5. If 5 divides a, then a is a multiple of 5. So we'll write a to be equal to a 5c. Substitute this a is equal to 5c in this equation. We'll get 5c the whole square is equal to 5b square. Now this translates to the fact that 25c square is equal to 5b square, or b square is equal to 5c square, where c is some integer. Now applying the same logic, it's quite evident that b square is divisible by 5, implies that b is divisible by 5. Go back to what we have here. We realize that 5 divides a, essentially meaning that a is divisible by 5. We have established based on that b is divisible by 5, which means that a and b are both divisible by 5. If a and b are both divisible by 5, then a and b cannot be co-prime, which means that a comma b cannot be co-prime. But let's look at what our assumption is. We assume that a and b are co-prime numbers. We've ended up getting that a and b are not co-prime numbers for the fact that both of them have 5 as a common divisor. If it's got any divisor other than 1 as a common divisor, then it cannot be co-prime. But we know a and b are co-prime. Something is wrong in this entire thing. What is wrong in this thing? That our assumption initially that root 5 is a rational number, right? Because this contradiction is happening. This contradiction happened because of incorrect assumption. What is the incorrect assumption we made? The incorrect assumption that we made is incorrect assumption that root 5 is rational is why we are seeing this contradiction. Hence we have proved that root 5 is an irrational number. Done. Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. So get it done today. And second thing, I want you to subscribe to this channel if you already haven't, and turn on notifications so that you get notified every time a new video is uploaded. And also, spread the word about this channel to your friends and classmates.